Hello, today I'll be briefly running through what my code does and how my program works. So let's go first into our header file. So here we have the three cameras and perspectives. Here we have the camera variable pointer. And then we also have a test triangle, which takes vector 3s as an input, which are the vertices, a flag variable for drawing the ray, and a bunch of vec3s, one for the mouse ray origin, one for its direction, one for the x and y, barycentric coordinates, which is what the GLM function returns, and then a vector 3 for the ones we want, which are alpha, beta, gamma, that we'll calculate afterward. Then we also have the world intersection coordinates, so from going to barycentric space to world space. So first in our setup, I set the background to black, all this, the camera, that's about it. And then for the test triangle, I added 3 random vertices that I wanted to be as crazy as possible. So let's move around a little bit so I can show you. And this is a bit of what the triangle looks like. Just like that. Yep. Okay. Now we can go to our draw method. So in the draw method, if we draw the mouse ray, so this is depending on input, this is a flag, then we set the color to white and draw that ray. And then we set the color to blue and draw a sphere at the intersection point of world coordinates with that triangle. Then we also set the color back to white so we can render a triangle and render it, of course. Next up, we have here in the key press functions, we have C to lock the camera. And we also have here the main function, which is calculate rate intersection. So all this does is takes an XY mouse position. Then we generate a ray at that mouse position, but we're in screen space. So we do is screen to world, that takes us to world space, and we call this vector D. Then we have origin, which is the camera origin, and then we're looking for a normalized direction between these two vectors, a normalized direction vector. So all we do is normalize the direction between D minus O, and that gives us a normalized direction vector that we can use to draw a ray. I also set those variables from the header file, these two right here, because we'll be using them later, and I call the function right here. This float t is basically a dummy variable. All it does is tells you the distance at which this ray intersected, which may be useful for ray tracing, but not for us in this homework assignment. So we intersect the triangle for the intersect triangle function, we pass a couple parameters. So we pass the origin, the normalized direction, the 3 vertices of our triangle, the barycentric coordinate output, which takes only an x and a y, alpha, beta, and t. And then we want to calculate the vector 3, alpha, beta, gamma, of that barycentric coordinate intersection. So all we do is do 1 minus x minus y, which is the same as 1 minus alpha minus beta. That gets you gamma, which is the third, because alpha plus beta plus gamma must equal 1. Then we get x and y, which are beta and gamma, which we get correctly. And all we want to do now is take that to world intersection coordinates. So in order to do that, we multiply the vertices times, the vertices, these ones, times that barycentric coordinate. So that takes us back into world space, and we add them together, of course. And in the end, we end up with a barycentric intersection at that point. And we draw a ray. And that's about it. So now let me demo how the program actually works and looks like. So let's move around over here. We can dolly in. Let me pan around a bit. And yeah, it was actually showing a bit. Here the ray is going kind of crazy because we're rotating the camera. So that changes the viewing angle. But if I lock the camera and I move my cursor around, you can see this. Let me move this to the right so we can actually look at the console. Let's zoom in a little bit so we can look at these values. So every time we get an intersection, we print that to the console. And you can see as I go out, we lose that intersection. So there is a question in this homework, which is explain what happens to the value as the mouse pointer is dragged to each corner of the triangle. So why don't we try that? I'm gonna go all the way to this corner. And let's look at what happened to the values. We see alpha, beta, gamma, and we're noticing that beta is reaching 1, almost 1. And then if we go to this corner, we see that our alpha is almost 1. And if we go to this corner, we see that our gamma is almost 1. So we're noticing that we're essentially staying at that vector. If we were to visualize this, add a triangle, so something like so. We have our points A, B, and C. Then we have this point at which we click on, and then this is scaled times alpha, beta, and gamma. I forgot how to draw gamma, something like this. So we're noticing that we're almost at A, because A alpha plus B beta plus C gamma is going to give us our world coordinate. And at this point, at A, if gamma is 1 and the rest of values are 0, we're just going to be here, at this corner. Same goes for the rest of directions. If beta is just 1, so this is 1, this is 0, and this is 0, we're just going to be here at this position. And same goes for C. So C right here, if gamma is 1 right here, and this is 0, and this is 0, because we must remember alpha plus beta plus gamma must equal 1. If this value here is 1, then these two must be 0. And in order to see that equation, we notice that if this is 1, we have to be at that point. So that's what we're noticing as we go to the different corners, that we just get closer to those values because of the equations that satisfy that. I must also demonstrate that this code works in any camera perspective. So let's try switching to another camera, such as from the side. And let's try drawing that. Let me lock the camera actually. There we go. And you can see your little dot renders at this intersection. Let's try another angle here. I think this is a top view. And we can notice that everything works perfectly. So that's about it. Thank you for watching.